In the name of God. Hello everyone, my name is Masoud. I'm a physics teacher. We are in Fairkhaw's website to explain physics curriculum for you. Right now, I'm gonna solve this problem, sample problem 1I, page 23 for you. I want you to be with us to solve the problem together. Firstly, I'm gonna, let's say, read the question for you. Find the distance between an 0.3 kilogram billiard ball and 0.4 kilogram billiard ball if the magnitude of the gravitational force is 8.92 times 10 to the power negative 11 Newton. So we have three information. Let's summarize the information. And what's unknown here? It says find the distance between the objects. There are two objects with different masses, 0.3 kilogram versus 0.4 kilogram. We look for distance between their centers, right? M1 is given, M2 is given, Fg is given. All the dimensions are unified. We don't need any conversion. Just rearrange the equation of universal law of gravitation, this equation, G capital, M1, M2, or M capital, M small divided by R squared. Just rearrange this equation for R. So R will be what? Will be radical G capital M, M1, M2 divided by Fg. Just write the, let's say, value, and that's it. Just substitute the value, and G, I want you to memorize G. G is a constant of gravitational, universal constant of gravitational, 6.67 times 10 to the negative 11. M1 0.3, M2 0.4, divided by 8.92 times 10 to the power negative 11. You can make it easy for you before you, let's say, you use calculator. You can simplify these exponents together, and under the radical, we have 6.67 multiplied by 0.3 times 0.4 divided by 8.92. I want you to calculate the, because you use calculator, no problem, but this is my note. If there is any, let's say, simplification, I want you to simplify them. If you observe these, let's say, numbers, for saving your time, right? Not to kill the time, actually. You can simplify the similar values, and R is equal to 0.3 meters. That's it. We have extra question, which is similar to this question, and this is the question of preliminary exam. Let me read it for you, and after that, we'll discuss it together, right? Let me read it for you. Extra question. Let me read. If the distance between two centers of 300 gram, right, 300 gram billiard ball and 400 gram billiard ball is 30 centimeter. You see, in this case, all of the, let's say, units are different. So we have to convert them into the units which are valid in SI, right? What's the approximate magnitude of the gravitational force? What do we look for? We look for Fg, right? We look for Fg. Fg is unknown. We look for Fg. Between them, sometimes in a national exam, G is given. But this is my advice to you, actually. I want you to memorize the value of G, right? So right now, we look for Fg. Fg is equal to G capital M1, M2 over R squared. Here, let's say, if you are not allowed to write, you are not allowed to use these, let's say, these values in grams and centimeter in the equation. You have to convert it. How do you convert it? For example, 30 centimeter How do you convert it into the meters? Either you divide it by 100 or multiplied by 10 to the negative 2. Either, you see, either you divide it by 100, maybe you are satisfied with this approach, or you multiply it by what? You multiply by 10 to the power negative 2. It's the same, yeah? It's the same. So whenever you multiply it by 10 to the power negative 2 or 100 divide by 100, you get the same answer, 0.3 meters, right? That's it. And for mass number 1, actually, 0.3. For mass number 2, you can say 0.400 gram becomes 0.4 grams. That's it. Just substitute the value. So this is G. M1, M2 divided by, let's say, centimeter. Yeah. Excuse me. About the mass. About the mass, I'm gonna, let's say, tell you another note about the mass, because mass is given in gram. How do you convert it to kilogram? Here, the conversion factor is different. It's different from the centimeter. In let's say, in R, we converted centimeter to meter by dividing by 100 or multiplying by 10 to the power negative 2. But here, for mass of objects, actually, because 1 kilogram involves 1,000 grams, that's why you have to actually either divide it by 1,000 or multiplied by what? Or multiplied by 10 to the power negative 3. It's the same. So either you divide it by 1,000, it doesn't matter. So 2 zeros cancel, and the answer will be 0.3. 0.3. Here we have the same thing. And for 100 gram, it's the same. So for R, we divide it by 100, but for mass, we divide it by 1,000. That's it. So we unified the dimensions. We substitute the values. I have a suggestion for you. Here, maybe some students don't know, teacher, where does the G exactly? What's the location? Where is the location of G exactly? Does it, let's say, does it go with the numerator or denominator? Of course, it goes with the numerator. You have to multiply G by M1, M2, because for any value, for any, let's say, variable, for any constant, for any fixed number, for anything in mathematics, there's a denominator of 1. For example, if you say x means x over 1, g means g over 1. That's why g, let's say, comes with m1 and m2. G goes to the numerator, not denominator. That's why you have to multiply this number by 0.3. So 6.673 times 10 to the power negative 11, multiply by 0.3, multiply by 0.4, right? Divided by 0.3 squared to find the last answer, which is 8.89 times 10 to the negative 11 Newton, right? Thank you guys for watching this video. Let's say, I want you to follow our videos, and bye for now.